exactly. Yeah. I don't like realize. What? No. Yeah, my okay, so then got it. This year, and then you're welcome.
So we do this.
It's crazy. They have 3 years of like essentially doing this. Okay. And walk the very good. If you get on the calculator, that's I'm not just saying words right now.
You just want to go.
You guys decide.
Hey guys, page 14. Sorry, I realized that I did not upload the key, at least not in the packet key. So let me go through the last problem with you here. So this is page 14. It says find the equation of the tangent line at x equals 2. So we just need to find the order pair and the slope from the derivative and then put it all into point slope form. So for part A, we can just go ahead and f of 2. Sorry, back to this. So f of 2, we can just plug into the function here. So 4 times 2 cubed minus 3 times 2 minus 1, and that gets us 25. So that's the order pair we'll be using for our tangent line. And then to build the derivative, we can just go through power rule. So power rule, we get 12x squared minus 3. And now f prime of 2 will get us our slope. So 2 in for x, we get 12 times 4, so that's 48 minus 3, which is 45. So we have everything that we need. We have our order pair. We have our slope. And then point slope form. Find points where the tangent line is parallel to y equals x plus 12. So basically, you want to know where on the graph, on this curve, where on this curve, let's say the curve looks something like this. Where on this curve is there a slope that matches the slope that we have here? So what is the slope of this line? 1, right? So I'm basically asking, where is this graph going to have a slope of 1? And we can use the derivative. So normally we use the derivative. I know this is a more straightforward way where we give it a location and we ask for the slope. We can also go the other way. We can give it a slope and then ask for the location. So the derivative can solve in both ways. You give it location, ask for the slope, or you give it slope and then in turn ask for the location. So we can plug 1 into the derivative, which is our slope. So we're going to plug 1 in directly for this f prime. So remove f prime, replace it with 1, and then we can just solve for x. So for part B, we can say 1 is equal to 12x squared minus 3. And then we can solve for x. Divide both sides by 12. 4 over 12 is 1/3. It's equal to x squared. So x equals plus or minus square root of 1/3. So when this graph is at negative 1/3 and also at positive square root of 1/3, obviously this is not accurate, but the idea is that there's 2 locations on the graph where the steepness is going to be exactly 1. So what we found is we found plus or minus root 1/3, and we have basically identified the 2 locations where this curve is going to experience a slope of 1. And then part C says find the equation of the tangent line. So we can plug plus or minus root 1/3 into the function to get the order pair, and then do point slope. We know the slope is 1, and we know the order pair. It's a little messy because plus or minus root 1/3 into the function, it's not going to give you a nice whole number. So, but yeah, that's basically what part C is doing. Plug in the order pair to get the y value, plug in the x to get the y values, and then use the order pairs and the slope to build your, basically we're just building these 2 tangent lines. And then D is sketching the graph, which is not, we're not going to have to worry about that. So let me just show you what B and C are so you guys can look at it. Okay, so it's messy because we'll have to plug in plus or minus root 1/3 into the function to get this y value, and it's not pretty, but we know this is now the 2 order pairs here. There's xy value here, and then the slope is 1. So we have our 2 tangent lines built there. All right, let's go to page 15. So with BC, we're going to introduce a lot of the derivative for derivatives for different families of functions a lot earlier than AB. With AB, I spent a lot of time with power rule, and then we later in the semester, then we introduced e to the x, natural log, sine, and cosine. But we're going to do a lot earlier in BC, so we have a lot more derivative rules to have to work through earlier in the year. So let me just highlight a couple of properties for natural log. So natural log of 1, these are good properties to know. Natural log of 1 is equal to 0. Natural log of 0 is undefined. E to the 0, exponential function, e to the 0, e raised to anything is always, anything raised to 0 is always 1. And then e and natural log are inverse functions of each other. So if we insert one into the other, they're always going to have a way of canceling each other out. So if I have e to the natural log of a, e and natural log will cancel out. I'm just left with a. And if I have natural log of e to the a, natural log of e will cancel out, leaving me with just a. So the big picture is that natural log and exponential functions are inverses of each other. So e to the x looks something like this. And the natural log of x looks something like this. So e and natural log are always going to be inverses of each other, which means that an order pair of one will be the flip-flop version on the other. So if there's an order pair of 0, 1 on e to the x, then there's an order pair 1, 0 on the natural log. So just understand that these are inverses of each other, and that's why they have a way of undoing and canceling each other if we were inserting one type into the other, or one function into the other. Okay, so with e to the x, this is the graph of e to the x. If I want to find the derivative for e to the x, the derivative is just e to the x. We have a little bit more involvement if this is more than the x, but right now, just understand that exponential functions e to the x has a nice relationship in the sense that the derivative is just basically itself. So e to the x not only describes the order pair of the function, it also describes the slope behavior of the function. So it's really convenient that the derivative is just itself. Natural log, which is this curve, has a derivative of 1 over x. We have a bit more involvement when chain rule comes into play. If this is more than an x, we'll talk about how we're going to build on top of this. But for now, we're just going to be using these basic parent graphs, parent derivatives. So if I were to insert any x value into 1 over x, it'll tell me the slope of this natural log of x. So we can tell that this natural log of x is really steep initially, but then it gets very gradual, but it stays positive. So if I were to do natural log of 8, natural log of 8 will be over here. You can tell it's barely positive, and that's represented with the derivative, which is 1 over 8. Or imagine all the way over here at 16 or 20 is 1 over 16, 1 over 20. It's barely positive, but the natural log graph will just continually be a positive slope, but then it's just going to get closer and closer towards 0. It'll always be positive, but this fraction is just basically going to get smaller and smaller. Okay, so let's do some practice with building derivative and order pair and writing tangent line equations. So number 4, find the value of the derivative at a given point. So if I have 3 natural log of x plus e to the x, find f prime of 5. The nice thing is that natural log of x and e to the x are separated by plus or minus. These are basically individual terms. We can just apply the derivative independently. So what do you think the derivative of 3 natural log of x would be? Well, first off, the coefficient is not going to go anywhere. It's just going to attach itself to whatever the derivative is. So the 3 is going to stay. And natural log of x becomes 1 over x, yeah. Or you can write it as 3 over x, that's fine. I just wanted to show that you got the coefficient that stays, and then the natural log of x that gets transformed. And then what does e to the x turn into? Just e to the x, so that's nice. So here's my derivative, 3 over x plus e to the x. So now f prime of 5, if I want to find the slope of this curve at this point, I can just plug 5 into the derivative function, and that will give me some numeric value, and that numeric value will correspond with the steepness of the original function graph, sorry, e to the 5th. And e to the fifth will be just some decimal value. But essentially, we've arrived at the slope of this graph at this point. All right, number 5, what is the slope of the line tangent to the graph of y equals natural log of x at the point 8? So I'm going to find the derivative first, then I'll plug 8 in to get the slope. So y becomes y prime to build the derivative. 2 natural log of x, we should be able to jump directly into our derivative rule. So 2 natural log of x becomes what? 2 times 1 over x. Right? Or we can write it as 2 over x. That's fine. So then y prime of 8 would be asking for the slope of the y graph at 8. So y prime of 8 would just be 2 times 1/8, which is 2/8, which is 1/4. Okay, try number 6. See if you can try that. Oh, just as a reminder, what do you think the derivative of e would be? 0. Good. E is just a number. It's an irrational number like pi, like around 2.7. But yeah, 2.7 is just a number, and that number is derivative of 0. Okay, so find the derivative, find f prime of x first, and then get the slope from the from plugging in 1. All right, so number 6, 4 natural log of x. The 4 is going to stay. Natural log of x becomes 1 over x. 3 stays. E to the x just stays e to the x. E goes to 0. So then we can plug in 1 in for all the x's. So I get 4 over 1 minus 3e. This is the exact slope of my curve at x equals 1. Okay, page 16. Everybody good? Page 15. All right, so here's page 16. We also are going to have to know the 6 trig functions derivative as well, but we'll start with the easiest one, which are cosine and sine. And basically, the sine curve and cosine curves derivative just basically involve each other. So sine's curve derivative is cosine, and cosine's derivative is negative sine. So they're basically using each other to describe the slope behavior of their own graph. So cosine's derivative is negative sine of x, and sine's derivative is just simply cosine of x. Again, there's more involvement. If this was like cosine of 3x or cosine of x squared minus 4, then the derivative is going to be a little bit more involvement, but we'll do that later on. We'll do that when we get to chain rule, but right now we're just going to learn just the basic parent functions derivatives. All right, so example, find f prime if the function is equal to 2 sine of x minus 5 cosine of x. If we want to build the slope behavior of this original function, we're going to build f prime. So what do you think 2 sine of x turns into? 2 cosine x. Yep, the 2 stays, and then the sine just turns into the appropriate derivative. And then what happens to cosine of x? Yeah, so we got to be careful that there is a change in sign here. We got to keep track of those two negatives. So let's build f prime. So f prime is 2 cosine of x. I'm just cleaning up here, plus 5 sine of x. Okay. Try 13 and 14. Build the derivatives and then find the slope. Right, so here's f prime of x. E stays as e to the x. Sine becomes cosine. Then we can plug 0 in. In this case, I think we can clean up a little bit. E to the 0 is 1. Cosine of 0 is 1. So that cleans up nicely to just add to B9. Okay, try 14. Find the derivative function first. Find f prime of x first, and then plug in pi into the derivative to get your slope. And I think we can clean it up a little bit. We can do unit circle values to clean up the trig function a bit, trig value a bit. Cosine becomes negative sine, e to the x stays as e to the x. And then once you have your derivative function, then find f prime of pi. So just keep in mind that anytime a problem is asking for f prime at an x value, at a numeric value, just keep in mind that it's 2 steps. Keep it as 2 steps. Build your derivative function first, and then and then find the slope next. Don't try to do all at once. I think that's sometimes a bit too much. So keep in mind, a lot of times this is a 2-step process. Build your derivative first, and then work in your x value. All right, so try 15. 15 says find the equation of the tangent line. So you're going to plug the x value into the function to get your order pair, build the derivative, find the slope, and then put it all in the point slope form. Okay, so find your order pair using your original function. Find your slope from your derivative function. We'll find the derivative first and then plug in the x value to get the slope. And then finally, put in the point slope form, replace m with the slope you found, replace x sub 1, y sub 1 with the order pair that you found. You can decide which order you want to do things in. I think on my key, I found the derivative first, then I found the slope, and then I found the order pair. But just as long as you know what each function's purpose is, f of x gives you location, f prime gives you slope. If you can understand that important difference, then you're not going to, that will help you avoid misrepresenting an order pair or slope.
It's getting,
Mhm.
how do you get I for the x value? For the,
Oh, sorry, it should be pi over 2. Pi over 2. You get pi over 2, comma pi over 2?
yeah.
Sorry, thank you. Okay, is that what you guys got? Good. Try 16. Same process. Use your function to get your order pair, use your derivative to get your slope, and then point slope form. Yeah, so anytime we learn a new derivative rule, we're going to go through this process, practicing building the derivative and getting the slope and language.
Do you want to simplify like that, or do you leave it?
Yeah, good question. On the AP exam, you can leave your equation unsimplified and you will not get any points taken off. And so, yeah, once you have your equation, you don't have to clean anything up. The reason that I'm going to this point is I think the only time you gotta go this far is if it's multiple choice on the AP exam and you're trying to get from this to that clear answer choice, then that's when I would bring it up. But if this pre-response, then I would encourage you to leave your answer unsimplified. Just so that you can save time and then, let's say you made a mistake from here to here. An AP grader would have to take off points here because even though everything here was correct, just a simple algebraic mistake would potentially cause you to lose points. So the strategy on the AP exam is once you get to your answer, leave it alone, don't touch it. First, you save time, and second, you potentially avoid making careless mistakes if you go a little further. All right, any questions? Okay, your homework is up to page 18, but I think we have enough time to make good progress. So go ahead and start page 17. Read the problem, and after a minute, I will kind of show each answer so that I want you to try the problem, and then I'll show the work. Okay, everybody okay with page 16? For number two, the strategy is find the slopes or derivative for both graphs and then set them equal to each other. So x plus y equals k. We know the slope is just going to be y equals negative 1x plus k. So the slope is negative 1. The derivative function, f prime. And then we can solve for x first and then use that to solve for k. So the line x plus y equals k, where k is a constant, is a tangent line to the graph. Y equals x squared minus 5x plus 2. So the connection point is that, well, you have a curve that's a parabola, and you have x plus y equals k, which if you rewrite it, it's basically a graph, a linear graph with a slope of negative 1. Because if you rearrange that x plus y equals k, you know that this line is really just a slope of negative 1. And because the line and the curve share the same slope at that point, we can set negative 1 into f prime to help us solve for x. And if we can solve for x, then we can find the location of that point. And if we have the location of that ordered pair, then we can go back to the equation to solve for k. So the connection point is use the derivative somehow to make some progress. Remember, this is a little bit more challenging because typically when we have a derivative function, we like to plug in a location and ask for the slope. But in this case, we know what the slope is, but we don't know the location. So we're working backwards here. We know the slope that we want is negative 1. So we're going to use that slope information to work backwards to solve for x. Once we solve for x, we can plug 2 into both these equations, because not only are they going to share the same slope at this point, they're also going to share the same y value at that point. So then we can set the two equations equal to each other, replace all the x's with 2's, and then the only variable unknown value to solve for is k. Something that I haven't explicitly gone over is the idea that there's a relationship between position and velocity. And velocity is just the first derivative of position. So if my position function is 3t squared minus 9t plus 7, then the derivative would be the velocity. And velocity would just be power rule 6t minus 9. So number 3 says, for what time t is the velocity of the object 0? So I know that I'm targeting a velocity of 0. So if I can replace v of t with 0 and then solve for t, when I solve for t, I get 9/6 or 3 times. Number 4, it says find a natural log of f prime of 3. So basically all of our work is trying to figure out what is f prime of 3. So to get to f prime of 3, we're going to first find f prime of x. So find f prime of x. We know e to the x, just e to the x. Plug 3 into the derivative, we get e cubed. So natural log of e cubed. We can clean this up because natural log and exponential function base e will cancel each other out. So the only thing left over is that 3 exponent. Okay, I'm going to work through number 5 with you. Okay, an equation of the normal line to the graph. So a normal line means perpendicular slope. So here's our function, g of x is x cubed plus 2x squared minus 2x plus 1 at x equals -2. So let's find the derivative, find the slope, and then flip it to get the slope that we really want, which is the perpendicular slope to the tangent line at this point. So g primes. We go through power rule for each. Plug in -2 to get the steepness of this curve at this point. Oh, sorry, g prime -2. I got -2. So get 12 minus 8, which is 4. 4 minus 2 is 2. So we get a slope of 2. This will be a slope for the tangent line, but we want a slope of the perpendicular line. So the slope that we really want, if my slopes of 1 is 2, then the slope that I really want is going to be what? -1. So we want an equation of the normal line. We can plug -2 back into the function to get the order pair. So once you have the order pair, and then we have the new slope that we want, we put it all in the fun slope form. Oh, but they want it in general form, so I got it into point slope form, and then I just rearranged it to get it to fit one of the answer choices. So -2 in for x, I get -8 plus 8 plus 4 plus 1, that's 5. So my order pair is -2, 5. My slope is -1/2. I put it into point slope form first, but my point slope form is not quite matching my general form, so I just multiply everything through by 2 to get that fraction to go away. And then once I have my equation without the fraction, I'm just adding and subtracting in a way that will match the form that they have, and that ends up looking like answer choice D. So this is really the only time you have to actually change your point slope form, is so that you can get it to match a multiple choice. But otherwise, if it's true response, you would just leave your answer in unsimplified point slope form, is what I would do. Number 6, the line 9x minus 16y is equal to 0 is tangent. So that's really, we always want to pay attention to these words there. So tangent is indicating that the line is going to share the same slope as the curve at a point. So that means we can work on building or finding that slope. So if I can find that slope of that line, that's going to kind of help me with my next step. So 9x minus 16y equals 0. If I get it into point slope form or slope intercept form, I get y is equal to 9/16 x. So therefore, the slope is 9/16. So I know that the slope of that line is 9/16. I know my derivative function is 9x squared. Remember, k is a constant, so that's just going to drop to 0. And remember, we can always use the derivative to help us find, either give it location and ask for slope, or give it slope and ask for location. So we're going to ask the derivative function, we want the slope of 9/16. Can you give me the location where you're experiencing that slope? So plug 9/16 into f prime, solve for x. If you solve for x, you get a location 1/4. And now we have our x value. We can find the y value using the first equation. And then take both the x and y value, plug into f of x to get your k value. So now you're just chasing that missing variable. But the hardest part is just trying to get to this x equals 1/4. If you know your x equals 1/4, you know that both the line and the curve must share the same slope in the order pair. So if I plug 1/4 in for x, I can solve for y. Once I have x and y figured out, I can use those two to help me solve for k. Okay, page 18. Getting a good chunk of the homework done just through classwork here. Oh, sorry, bell's about to ring. Okay, so your homework to finish up to page 18. And there's a link on my website. The very top of the page has the key to the packet. So check that as you work through it. Is anyone else not going to be here tomorrow through Friday? See you guys tomorrow.
Bad minds. Yeah, I think it's Dave. Okay, I think, you know, so I know.
Yes, sir. Bye. See you later.
Yes, it's the, dude, that absolutely, how do you, is you just make, we actually. You make it all positive. Yeah, whatever you. No, you do, yeah, make it positive. So. Exactly, no. Well, we do.
Thank you guys. Bye. See you.
Yo, like, Arya. Rainbow, Arya just goes out here, he's so smart. And Mr. Dana, like, I'm not getting talked. Oh, it's good, it's sharp. Ken would have been like a thing where if I just not just written live, I've never changed what he said. 57 because you know the study that you're gonna get 100. I studied the site, I got 57. Nothing on this study, guys on this. That kind of is pretty. Yeah, B, second semester because of that. Nice. If you don't get to know the scientist, nice. First question about science. I spent every 20 minutes just staring at the first question. The entire quiz was asking about the science.